So something many of my Algebra 1 students ask me is, what is factoring and foiling? What does it entail and how do we do it? Today, I'll be covering with you the general gist of what factoring and foiling is, as well as providing a few example questions for you to better your understanding of how to do so. Let's get started. So, the first thing we need to understand is what the steps are in factoring. We follow the FOIL method, otherwise known as first, outer, inner, and last. What does this mean? It means that in any situation where you are given two binomial factors, you multiply them in the order given by FOIL. F stands for first. Our first step is to multiply the first terms of both our binomials together. In this case, we have x and x, which multiply to x squared. Our next step is to deal with our outers, or our outside terms. You'll notice that we have x and y, which multiply together to get xy. Our next step is inner. Our next step is to multiply our inside terms together. In this case, we have y and x. When we multiply these together, we are left with, once again, xy. Our second to last step is to multiply our last terms together, the last ones that show up in our binomial. You'll notice in this case we have positive y and positive y. When we multiply these together, we are left with y squared. Now comes our final step. You will notice that I have left all values that we have calculated on the left side of your screen right here. What you will do is you will add all of these terms together to create our final polynomial, and you will simplify it in order to get your final answer. In this case, we have x squared plus xy plus xy plus y squared. Xy and xy are the exact same variables, therefore we can combine them, and we are left with x squared plus 2xy plus y squared. And that's it. That is all that is to do with foiling. Now, let's work on some example problems. In the first example problem that I've shown you, this is an example of what we call a perfect square binomial pattern. It involves a binomial as well as the inverse of the binomial given through x plus y and x minus y. While we perform the FOIL method, we can come out with the following expression of x squared plus xy minus xy minus y squared. Do you notice anything? Well, you'll notice that xy and negative xy cancel each other out. Therefore, all we are left with is x squared minus y squared. Now note, this pattern works for all versions of a perfect square pattern. In other words, you will see that no matter what we input for our values, whether it be x plus 7, x minus 7, x plus 3, x minus 3, x plus 6, x minus 6, we are always left with the answer of x squared minus y squared, or, in these cases, x squared minus 49, x squared minus 9, and x squared minus 36. So, pretty simple. Now we go to example problem number 2. Example problem number 2 revolves around the actual FOIL process. You must make sure that you follow the steps carefully. Here's an example. You'll notice that when we perform our FOIL, I have once again left our values on the left for you. X times x is equal to, or for our f, it is x times x. For our O, it is x times 12. For our I, it is negative 5 times x. And for our L, it is negative 5 times 12. When we simplify all of these values together, we get f is equal to x squared, O is equal to 12x, I is equal to negative 5x, and L is equal to negative 60. When we put all of these values together into our final polynomial, we will find that we get x squared plus 12x minus 5x minus 60. When it's simplified, we are left with x squared plus 7x minus 60. And you're done. That is your final answer. Now, for the last example problem that we have, it looks complicated, but it's actually the exact same solution as well as the exact same steps that you have taken for our previous problems. For our third example problem, we have binomials that have multiple variables as well as high level of powers in our binomials. In this case, I have chosen the example x squared plus 12y times x squared minus 6y. Our steps are the exact same as example problem number 2. For our f, we multiply x squared and x squared together. For our o, we multiply x squared and negative 6y together. For our I, we multiply 12y and x squared together. And for our L, we multiply 12y and negative 6y together. We will find that f is equal to x to the fourth power, o is equal to negative 6x squared y, I is equal to 12x squared y, and L is negative 72y squared. When we put all these together, we are left with x to the fourth power minus 6x squared y plus 12x squared y minus 72y squared. You will notice that negative 6x squared y and 12x squared y both have the exact same variables. Therefore, we are able to simplify it. And thus, we are left with x to the fourth power plus 6x squared y minus 72y squared. And you're done. Thank you for following along, and I'll see you in the next one.